Section 3.2, Theorems for perpendicular lines. The first theorem, 3.1, says that all right angles are congruent. So if the measure of angle A is 90 degrees and the measure of angle B is 90 degrees, they're both right angles, which means that angle A is congruent to angle B. So any angles that have the same measure are congruent. So if they're both right angles, they're both 90 degrees, which means that they are congruent to each other. So Theorem 3.2 says that if two lines are perpendicular, then they intersect to form four right angles. So that means that if line N is perpendicular to line M, then all four of these angles are right angles. So let me just reword that here. If you know one is a right angle, then you know all four are right angles. So if two lines are perpendicular, so if you know one is a right angle, then you know that all four of these are right angles. Which means that if they're all four right angles, then they're all four 90 degrees. So they told me that line R is perpendicular to line T, which means that since angle 3 here is a 90 degree angle, and since line R is perpendicular to line T, we also know that these other three angles are 90 degrees. And line R is perpendicular to line S. So since angle 5 is a right angle, we know that all four angles here are right angles. So is the statement true? Is angle 3 congruent to angle 5? Well, angle 3 is a right angle and angle 5 is a right angle, so yes, and that is by the first theorem that we looked at. They're both right angles and all right angles are congruent. That's how we know angle 3 is congruent to angle 5. Angle 4 is congruent to angle 5, so just like I had marked previously, we said that all of these are 90 degrees and all of these are 90 degrees. So is angle 4 congruent to angle 5? Yes, they're both right angles. But how did we know that they were both right angles? That was by the theorem 3.2. So we know by theorem 3.2 and then theorem 3.1 that angle 4 is congruent to angle 5. And last, is angle 2 congruent to angle 3? Well, like we said, all four of these are 90 and all four of these are 90. So is angle 2 congruent to angle 3? Well, we know angle 3 is 90 degrees, but we don't know the measure of angle 2. It might look like it's 90 degrees, but that doesn't mean that it is 90 degrees. So no, we don't know that they're congruent because there's not enough information. So theorem 3.3 says that if two lines intersect to form congruent adjacent angles, so congruent means the same measure, adjacent means right next to. So here we have angle 1 and angle 2 are congruent because they both have the one tick mark, and they're adjacent angles because they're right next to each other. So these are congruent adjacent angles, then the lines are perpendicular. So my lines are perpendicular. So since angle 1 is congruent to angle 2, we know that N is perpendicular to M. Well, why is that true? If these make a straight line and they're the same measure, the only two things that they can be is 90, right? 90 plus 90 equals 180. Those are the only two measures that would be the same that would add up to 180 degrees. Therefore, if they're both 90, we know that the two lines N and M are perpendicular. So if you look at these helicopter blades to determine if angle AXB, which is marked here, and angle CXB is marked here, we want to determine if they're right angles. Well, they are congruent because they both have one tick mark. They're adjacent because they're right next to each other. So congruent adjacent angles means that they are perpendicular. So since they're perpendicular, that means that they are 90-degree angles. So yes, by the last theorem, 3.3 that we just looked at, which means they are right angles because they are congruent adjacent angles. They are congruent, they both have one tick mark, and they're right next to each other, which means that they both have to be 90. And our last theorem says that if two sides of adjacent acute angles, so 3 and 4 are adjacent and they're acute because they're less than 90 degrees each, then the angles are complementary, so that means that they add up to 90 degrees. So since these two rays, EF and EH, are perpendicular, we know that angle 3 plus angle 4 is going to add up to 90 degrees. Because that's what it means to be perpendicular, is a right angle. So we know these two are going to add up to 90. So, since they told me that ray EF is perpendicular to ray EH here, we know that this is 90 degrees, because that's what perpendicular means. So that means that 6y plus 30, if we add the two angles together, they're going to sum up to 90 degrees. So subtract 30 from both sides, 6y equals 60. Divide both sides by 6, and we get y equals 10. If I were to ask you for the measure of angle FEG, then you would plug 10 in for y, and you would find that the measure of this angle is 60 degrees. Right. So now if you check, 60 plus 30 does add up to our 90 degrees, so we know that that's right. All right, they told me that angle EFG is congruent to angle GFH. So this is theorem 3.3. We have congruent adjacent angles. So if they make a straight line and they're the same measure, we know that the only thing that both of these angles can be is 90 and 90. So we know that 5x equals 90. Divide both sides by 5. And we get x equals 18. A longer way that you could do this that would still be correct is that if we know this, so let's erase this. If they said they're congruent, then we also know that this side is 5x. So then if you didn't recognize that each angle was 90 degrees, you could say that 5x plus 5x equals 180 because they make a straight line. And you would still get x equals 18. That's a longer way, but it's still correct. All right, so they tell me that that ray KJ is perpendicular to ray KL, so we know that this is a 90-degree angle. And they also told me that the measure of angle JKM, so that's right here, is congruent to the measure of angle MKL, which is right here, which is already marked in the picture because we have Z and Z. So we know that Z plus Z adds up to 90 degrees. So 2Z equals 90, divide both sides by 2, and we get Z equals 45 degrees. Well, I guess just 45. But if you plug it in, then each angle is 45 degrees. Here, they told me that ray AB is perpendicular to ray AD, which means that I know this is a 90-degree angle, which means that my two angles are going to add up to that 90 degrees. These are two adjacent acute angles, and so we know that they add up to 90. So we're going to subtract 36 from both sides. So 9y equals 54. Divide both sides by 9, and we get y equals 6. I just want to caution you, these are not equal to each other, even though they look like it. 9y does not equal 36. There's nothing telling you that they are congruent, so we do not want to set them equal. All we know is that they add up to this 90-degree angle right here. So we just know that we can add them together to equal 90.